Alright, here's the second video that had no narration. So, question number 2. Name the parts of glycerophospholipids, triacylglycerols, and sphingolipids. So we're going to start off with the triacylglycerols because these are, in my opinion, the simplest ones. So, the backbone of triacylglycerols is going to be glycerol. Alright, it basically has 3 carbons. They're connected to hydroxyl groups. The one on the right should be a CH2. The other part of a triacylglycerol are going to be the fatty acids, right? And the fatty acids normally have a carboxylate at one end, but that carboxylate is going to be joined to the alcohol of glycerol. And the remainder of the hydrocarbon tail is going to be pointing downward, right? So we basically end up with an ester bond between the fatty acid and our glycerol, right? And the hydrogens end up leaving from the fatty acid. So I'm just trying to draw a shorthand. So 2 parts of a triacylglycerol are glycerol and 3 fatty acids. All right, the glycerophospholipids are our next most complex one. All right, they have the exact same backbone. They have a glycerol backbone. All right, which I'm just going to draw as 3 carbons initially, and then I'm going to decide later on that I need to draw the hydrogens just for some reason. All right. Now, the glycerophospholipids, they are going to have 2 fatty acids attached to their carbons. So we have the 3 carbons at the top, 2 fatty acids dangling off of them attached to the alcohols. All right, the 3rd carbon, or the first one in this drawing here, that oxygen is going to be attached to a phosphate. So hopefully you guys all remember the chemical structure of phosphate. So it should have a negative charge on it. All right, and at the top of this phosphate, there's going to be an R group, a head group. This could be choline, ethanolamine, inositol. It could even be as simple as just a hydrogen. All right, so basically then our glycerophospholipids are going to have 4 different components to them. All right. They're going to have the glycerol part. They're going to have 2 fatty acids. They're going to have a phosphate, and they're going to have the head group. Now, the sphingolipids are our last class of, I mentioned in this question. They're going to be significantly different in that they have a different backbone, which is either sphingosine or dihydrosphingosine. All right, this molecule, sphingosine, dihydrosphingosine, starts out very, very similarly to glycerol. All right, it's going to have 3 carbons. All right. Some of them are going to have OHs on them, as we will see in a second. But sphingosine and dihydrosphingosine bring along their own alkane tail. All right, so that 3rd carbon already has an alkane attached to it. All right, and it's not attached by an ester linkage or anything like that. Another difference is that, as here, the 2nd carbon, all right, it is going to have an amine group instead of an alcohol. All right, the first group, carbon, still has its alcohol as shown here. All right, so this top portion of the molecule looks a lot like glycerol, the only difference being that it has an amine on it. All right, now this amine is going to be a very important part of the molecule. This is going to be the site of attachment of a fatty acid. All right, so in a second here, I'm going to erase some of the hydrogens and start attaching the fatty acid. Oh, there is the alkane tail, in case you couldn't tell before. All right, we are now erasing positive charge and the hydrogen. All right, so the way the fatty acid is going to be attached is through an amide bond. So what used to be the carboxylic acid of the fatty acid now via condensation reaction forms an amide functional group with the sphingosine. All right, so sphingolipids only have 1 fatty acid attached. All right, up here at the 1st carbon now, that oxygen can be fused to a variety of different things. All right, and these are the different classes of sphingolipids. All right, the first thing that can be fused to is going to be a phosphate with either an ethanolamine or a choline. All right, this family of sphingolipids are the sphingomyelins. So sphingomyelins will have a phosphate there. I'm just drawing it as a P with a circle. All right, with either choline or ethanolamine. hanging off of it as a head group. All right, so those are the sphingomyelins. All right, we can also have other head groups on there. Instead of phosphates, we can instead have sugars. All right. Now, if we have just one sugar attached up there, and the sugar will either be a glucose or galactose typically, all right, those are the cerebrosides. Cerebrosides have one sugar. Instead, there's a whole nother class of sphingolipids called the gangliosides that are going to have a whole tree of sugars attached to that first carbon atom of sphingosine. All right, they're going to contain glucose, galactose, and also a strange sugar called sialic acid, all fused up in there. All right, so the parts of our sphingolipids then are going to be the sphingosine. They're going to have one fatty acid, and they're going to have a head group, which can either be sugars or phosphocholine or phosphoethylamine. Sorry. All right, there's the sphingosine. There's our fatty acid. And up on top, we have the head group.